Okay, class. We're going to cover section 1.6. And 1.6 is basically solving other equations. Solving other equations. Okay. And we're going to be looking at 6, I think, different types of equations. Yeah, 6 different types of equations. Some of them I'm going to do just one example on. Others I'm going to do more than one example. So before we do that, they're going to, in the book and stuff, they're going to talk about the degree of a polynomial. The degree of a polynomial is the largest exponent on a polynomial. So if you have a polynomial like this, the degree is 1 because the exponent on the x is 1. If you have a polynomial like this, the degree is 2 because the largest exponent's 2. If you have a polynomial like this, then the degree is 7 because 2 plus 7 here is not 7, it's 9. 2 plus 7 is 9, so the degree of this polynomial is 9. Okay, you add up the exponents in each term. So that's just understanding the language. Okay, so in a lot of these, the first few ones we're going to be looking at how to solve, or at least the two, how to solve a problem when it's not a quadratic, meaning the degree is greater than 2. Okay, so we're going to look at polynomials. Okay, and there's special cases. You can't solve all polynomials that have larger degree. The first one, however, is the easiest. We'll start easy first, GCF. GCF is any type of equation that kind of looks like this. Okay, you're going to move the 27x squared to the other side. You have this, and you notice there's a GCF that you can factor out. You're going to factor out the largest GCF possible. Largest is going to be 3x squared. That'll then leave you with an x squared minus 9 equals 0. Then what you do is you break it up into 2 parts. Okay. This is going to give you x equals 0. Over here, you're going to add 9 to both sides, maybe, and you're going to have x squared equals 9. You're going to take square root of both sides, have plus or minus, so x equals plus or minus 3. And so we get solution is x equals 0, 3, or negative 3. Okay. Another example would be on this one, 4x4 minus 12x squared equals 0. Here we can factor out a 4x squared, give you x squared minus 3 equals 0. You're going to break it up. 4x squared equals 0. The only solution to that is when x equals 0. So that's x equals 0, and then you're going to have x squared minus 3 equals 0. Add 3 to both sides. Get x squared equals 3. Take square root of both sides, and you get x equals plus or minus square root of 3. That'll give you solutions of x equals 0, negative square root 3, positive square root 3. Okay, so that's if you have a GCF. So they're kind of simple. They're usually 2-term expressions, maybe even 3-term that has a GCF that you factored out. And we did one of those in the last sets of videos. Okay, the next one is factor by grouping. So this one, it usually looks something like this. All right, we're going to move everything to one hand side. Okay, I left a space here intentionally because I know I'm going to put a plus there when I factor by grouping. And what you have to do is you just have to try it. It's either going to work or it's not going to work. A lot of these are trial and error. You try various different things, they don't always work. So I'm going to put in my parentheses, put a plus here. Okay, and then you're going to factor out what you can. Well, we can factor out an x squared out of the first one. That'll give you with 2x plus 3. And what can we factor out of the second one? We can factor out a negative. You're doing it right if we can make this term equal to this term. So if we factor out a negative 4, that'll give us 2x minus 3. Oh wait, plus 3. When I pull this over, it should have been minus. Okay? My bad. So these are the same. So we did it right. And then you end up factor by grouping. Okay, and then you're gonna take each and set it equal to 0. So you have x squared minus 4 equals 0, and 2x plus 3 equals 0. This guy here, x squared minus 4, is two solutions. It's x equals plus or minus 2. If you plug positive 2 into here, you get 4 minus 4 equals 0. You plug negative 2 in. Negative 2 times negative 2 is 4. 4 minus 4 is, again, 0. This one, it's going to give you x equals negative 3 halves. And you find it by subtracting 3 from both sides and then dividing by 2, right? Okay? So this will be your solution to this. So how you tell these is usually you're going to have 4 terms. And you just have to group them in descending order on one side, put your parentheses in, and when you factor out as much GCF as you can, you'll end up with these two being the same. If they're not, either you've done it wrong or it can't be factored this way. Okay? So these are just special cases. Okay. Let's move to the next one, which is radical equations. How do we solve radical equations? So the third type is radical equations. Well, radical equations are things like this. What's the solution to that? Well, we know the solution to that if we square both sides, all right? And we know x equals 81, and then you have to check it. Is the square root of 81 equal to 9? Yes. So we know that that's a solution. So in general, that's what you're going to do. I'm going to go through the process here. Okay, and then we're going to do a couple more examples on this one. So step one. Step one is move everything except one radical to the right-hand side. Except one radical to the right-hand side. Okay, that's the first step. So right now you should have one radical on the left-hand side and everything else on the right-hand side. It might have other radicals, might be a combination of different things. Step two is you're going to raise to the power of the radical. Raise both sides by the power. Okay. Step three is repeat steps 1 and 2 if there's still a radical. Okay. Step 4 is if you've gotten rid of all the radicals, you're going to solve it. And then step 5, it's very necessary in these problems to check. Because you can get what's called an extraneous solution when you're doing this technique. So if there is a solution, you'll get it, but you also might get things that are not solutions as well. So you always have to check on these problems. Normally we just say check just to be thorough, but on these problems, you need to always check. Okay, I'm going to go through a couple examples. Let's look at the first one. Okay, so here is a radical equation. what we're going to do is we're going to move everything except for this radical here to the right-hand side. So we're going to do it by subtracting 3 from both sides. All right. Now there's only one radical on the left-hand side, and it's a square root, so we're then going to square both sides. Okay. Square and square root cancel. This you're going to have to multiply out. It's x minus 3 times x minus 3, which will give you x squared minus 6x plus 9. Okay. Now you're going to just solve it by moving everything over. So let's just move these over. Okay, and you're going to get x squared minus 7x plus 6 equals 0. So this is a regular quadratic that we can either factor or use a quadratic formula on. This one we can actually factor because 1 times 6 is 6. 6 does add to 7. So 6 times 1 is 7, and they're both going to be negative. So this will factor into x minus 6, x minus 1 equals 0. And you're going to get solutions x equals 1 and x equals 6. Now, one or all of these could be extraneous solutions, so you're going to have to check them. You check them by plugging them in. So, does square root of 1 plus 3 plus 3 equal 1? So I plugged 1 into the original up here, right here. I plugged 1 into that equation. And then 1 plus 3 is 4. Square root of 4 is 2. Does 2 plus 3 equal 1? No, it's 5. 5 does not equal 1. So this is an extraneous solution. Now 6 could still be an extraneous solution, so we got to check it as well. So you're going to have square root of 6 plus 3 plus 3 equals 6. So 6 plus 3 is 9. Square root of 9 plus 3 equals 6. Square root of 9 is 3. 3 plus 3 does indeed equal 6. So this is a solution. Now, they could both be solutions on these. Don't just assume that one's extraneous and one's a real solution. You could have all the answers be real solutions. You could have all be extraneous solutions, or you could have any mix in between. So it's very important you check on this step. Okay. Now that's how you basically solve these. What about if you have more than one radical expression? Let's look at one of those. So here it has 2 radical expressions in the equation. Well, if you look at the steps, it says move all but one radical to the right-hand side. So I need to move everything but the one radical to the right-hand side. So I'm going to move this guy over, because I only need one radical. Okay, so I did that. So that's step 1. Step 2 is now to raise to the power of the radical. The power of the radical is 2, it's 1/2. So we're going to raise to the power of 2, both sides to the power of 2. Okay, that here will cancel. Here, what you're going to have to do is you're going to have to FOIL this out. It's going to be 2 times square root of x plus 3 times 2 times square root of x plus 3. Okay, and then you're going to FOIL it out. 2 times 2 is 4. 2 times square root of x plus 3 is 2 square root x plus 3. And then you're going to go this times 2. That's going to give you another 2 square root of x plus 3. And then finally, you're going to multiply the square root of x plus 3 times square root of x plus 3, which is going to give you square root of x plus 3 squared. Okay? So that's FOILing that out. Now, if you've done it right, your middle terms should combine, and they do. And then the end term should cancel, the square and the square root. We end up with that. Okay? So here we've worked it out. Notice we now only have one radical expression in our equation, which was, you're going to move down by 1 each time you do this if you're doing it right. So what we're going to do is we're going to subtract, move everything to the, I don't know, we're going to move this over here and all these over here, I guess. So I move that over, it's negative 4 x plus 3. Over here it's 4 plus x plus 3 minus x minus 5. So I move them over, I change the sign. Here they cancel. And then combine like terms, 4 plus 3 is 7, 7 minus 5 is 2. Okay, now before we raise both sides to the power of 2, I would go ahead and move the 4 over by dividing both sides by negative 4. Okay. Now square both sides. Subtract 3 from both sides. Turn 3/4 will be, which is negative 11/4. So x equals negative 11/4. Then you have to check to see if it works. So this is how you go about it, and you check it in the original one, which is way up here. And so let's look at it. So the original one was x plus 5 minus the square root of x minus 3 equals 2. That was the original one. I'm going to plug negative 11/4 in there. Okay, like that. Now, what you're going to notice here is this doesn't work out. That is going to be an imaginary solution, and we're only interested in real solutions here, not imaginary in this section. And so it's not going to work out. You're not going to get 2 because we get 2 here. So then this is the extraneous solution, the negative 11/4, and so there is no solution. So this is the possibility, no solution to this radical. But I at least made you go through the steps of how to solve it, which is valid. Okay, I only have a little bit of power left on my tablet, so I need to go charge before I finish up this section. So we'll do this in 2 videos as well. So next time we're going to talk about rational expressions, rational equations, substitution equations, and absolute value equations, how to solve those.